Good morning students. Today we are going to discuss few important topic from the chapter 2, that is your units and measurement. Now last class we discussed what are the uses of dimensional analysis. There are 4 uses. Now in this class we are going to discuss 2 uses out of that 4 uses. Now fundamental quantities are your mass, length and time, and the symbol for fundamental quantities are mass for capital M, length for capital L, and time for capital T. So these symbols basically used to define dimension of any physical quantity. Apart from this, some other symbol is also used just for temperature, Kelvin, for current, ampere. But in general, the 3 fundamental quantities, mass, length and time, is used to denote any physical quantity dimensionally. Now if you want to define dimension of any physical quantity, you must have to physical quantity in the sense the derived physical quantity. Otherwise the fundamental quantities are same, no, mass, length and time. But if you have to express the derived physical quantity in terms of dimension, then you have to use the formula. For example, if I ask you to define the dimension for force, what formula you are going to use? That is your F equal to ma, mass, acceleration. If I ask you to define the dimension for acceleration, what you will do? You will use the formula acceleration equal to velocity by time. If I ask you to define the dimension for velocity, what you will do? You will use the formula velocity equal to displacement by time, or speed equal to distance by time. So after that, if I ask you to write the dimension for distance, so use definitely length, that is your capital L. So if you want to write the dimension of any derived physical quantity, you must have to know the formula by which you can express that derived physical quantity. So let me try to start the first application or first uses of dimensional analysis. Number 1, that is your conversion of one system of units into another. So you can convert one system into another system by using dimensional analysis. Now how? Let me try to discuss. Now in previous classes already we have defined a physical quantity can be expressed by using 2 parameters. One is your numerical value, another one is your system of unit. So first statement, what we have written, a physical quantity capital X can be written as X equal to small n u, where n is your numerical value and u is the system of unit. Okay, for example, length equal to 10 centimeters. So 10 is your numerical value and physical quantity is your length. And if I say 10 centimeter, then centimeter is the system of unit. So to express any physical quantity, you need 2 parameters. One is your numerical value, another one is your system of unit. So here we have considered the physical quantity X. So X equal to nu. Now if we take 2 different systems, maybe one is your CGS, another one is your MKS, or any 2 systems. So what changes will come? Numerical value and the system of unit, obviously. For example, if I say 1 meter equal to 100 centimeters, so you have seen that numerical value changes. One is your 1, another one is your 100, because it has 2 different systems. One is your MKS system, another one is your CGS system. And also in last class we defined that it is inversely proportional, numerical value and the system of unit. If the system of unit is of high, then the numerical value is your less, and vice versa. So in 2 different systems, we are measuring the physical quantity and we are getting the numerical value n1 and n2 with the system of unit u1 and u2. Now in different system, fundamental quantities have different value, no? Because in CGS system, mass can be expressed by gram, whereas in MK system mass can be expressed by kg. In CGS system the length can be expressed by centimeter, whereas in MK system length can be expressed by meter. So in different system fundamental quantities have different values. So but the system of unit with the numerical value is identical in different system. In different system means if you consider the same physical quantity, then definitely the product remains identical, because 1 meter equal to 100 centimeter. No, so you are using the what quantity, physical quantity, length, but the system of units are different. No, so what you can write, n1 u1 equal to n2 u2. So u1 you can express with m1 l1 t1. So as this is your unknown physical quantity, then definitely its dimension is also unknown. So that's why we have expressed the dimension in terms of a, b and c. But different system, but the dimension should be identical, no, because same physical quantity. That's why the exponents are identical in both the system. So n1 m1a l1b t1c, and n2 m2a l2b t2c. So you see, this is a very important point. If you have to express dimension of any physical quantity to denote that physical quantity as a dimension parameter, what you have to do, you have to enclose that physical quantity by the third bracket. So if you keep the physical quantity in third bracket, then it is to be understood that you are defining the dimension of that physical quantity. So n1 e1 m1a l1b t1c, n2 m2a l2b t2c. So if you change the place, so n2 equal to n1, after simplification, m1 by m2a, l1 by l2b, and t1 by t2c. So this is a master equation which you are going to use for the numerical or for numerical analysis or for numericals. So the equation 3 can be used to find the numerical value in new system of units. So new system we are considering n2, numerical value you can find. n2 u2 is your new system. So this formula we are going to use in this numerical. Convert 10 arg into joule. So 10 arg into joule. So you have to find the numerical value of 10 arg in terms of joule. So let us consider, and one parameter is your known, one in the sense one subscript, n1 10 m1 as it is arc, so it is your CGS unit of work. No? So m1 1 gram, l1 1 centimeter, t1 1 second, and as joule it's for work. So mk system, m2 1 kg, l2 1 meter, t2 1 second, and n2 we have to find. Now as the physical quantity is your work, so we have to define the dimension for work. So work dimension is your what? Force distance. No? Force is your m1 l1 t minus 2, and if you multiply with the distance, that is your length, then it comes out to be your m1 l2 t minus 2. So we are going to use this expression, n2 equal to n1 m1 by m2 a l1 by l2 b t1 by t2 c. So what we will do, so the exponent work done is your force into distance. So force is your m1 l1 t minus 2, and distance is your length, so m1 l2 t minus 2. So a is your 1, b is your 2, and c is your minus 2. So we have to write the formula here, n2 equal to n1 m1 m2a l1 l2b t1 t2c. So then we have to substitute the value. So m1 l1 t1 in CGS 1 gram 1 centimeter 1 second, and mk system 1 kg 1 meter 1 second. So 1 gram, so 1 kg in terms of gram, it should be 1000 gram, no? So gram goes up, it should be 1000. 1 centimeter, meter is 100 centimeters, so centimeter goes up, so it should be 1 by 100, and time part almost means cancel out, 1 second is identical. So if we simplify, you will get what? 1 by 10 to the power 6. No? 10,000 goes up, so 100 will be there. So 1 by 100 3 times. So 1 by 100 into 1 by 100, 1 by 100. So it means 1 by 10 to the power 6. So n2 equal to comes out 10 to the power minus 6. So as per the question, 10 arg equal to 10 to the power minus 6 joule. So you are converting one system into another system. with different numerical value, obviously. Now the second application which you are going to define is here to check the correctness of the given physical equation. A physical equation, what you have written, a physical equation is dimensionally correct if the dimension of each term on both sides of the equation are same. Okay, left hand side and right hand side both have identical dimension, then the equation is correct, otherwise it is wrong. So one numerical we have taken, check the dimensional consistency of the equation of escape velocity. You will get this one later on. We have used directly the formula v equal to root over 2gm by r. G is a gravitational constant. So Newton's law of gravitation already you have got, I think, F equal to g m1 m2 by r square. So you can find the dimension for g using that formula. And m is the mass of the earth and r is the radius of the earth. So in solution part, what you have to do, you have to find the dimension for each of the parameter. So v is your L1 t minus 1, g part you try to find it out by using the formula F equal to g m1 m2 by r square. So you will get m minus 1 L3 t minus 2. Check it out. Okay, if you can't, then tell me, I'll try to solve, show you. So mass m1 and radius is your length, so L1. So substitute this value in right hand side, m minus 1 L3 t minus 2 m1 L1. So m minus 1 m1 goes off, L2 t minus 2, so root over, so exponent is your half, so it goes L1 t minus 1. So L1 t minus 1 is nothing but the velocity. So this is equal to the dimension of left hand side. So you try the numericals, similar numericals, okay, and try to sort out. This is a very important topic. You will get the numericals as well as the uses part of dimensional analysis. But before winding up, let me to tell you that whenever there is a class, please download the materials at that very day, because it is very tough for me to keep the videos in the mobile, because mobile does not have sufficient space and I have to take 2 classes, 11 and 12, and I have to keep all the materials, so it's very tough. So to clear the space, I used to erase. So please download at the very day of your class. Thank you.